3 separate asteroids passed closer to Earth than the Moon within a single week: May 7th, May 9th, May 11th, each one larger than the last. All of them came closer than the Moon itself. Not a single major news outlet covered it in real time. The question is why? These were not near misses in the distant, abstract sense that astronomers use when they want to avoid public panic. These objects crossed inside the Moon's orbital distance, the zone we actually live in, 3 times in 7 days. That has never been publicly logged before in quite this sequence. And here's the part that nobody in the official briefings wanted to say out loud. We did not see any of them coming. Not until they were already making their approach. The detection window for each one was measured in hours, not weeks, not months, hours. By the end of this video, you're going to understand exactly what happened during the first 2 weeks of May 2026, why a geophysicist publicly described this week as statistically anomalous, and what the detection failure actually means for every early warning system currently funded by your tax dollars. We are going to walk through each of the 3 objects individually, the exact distances, the exact sizes, and the exact reason none of them showed up on a single telescope until the last moment. Then, we're going to place this week inside a larger pattern that started forming in March 2026, a pattern so unusual that researchers are still trying to explain it. Stay with me through the first half of this video because the convergence of what I am about to show you is not something you can get from a headline. The data only makes sense when you see it assembled in one place. And what it adds up to is a problem that planetary defense officials have been quietly worried about for years without ever quite saying it publicly. Here is the thread I want you to hold on to for the next 14 minutes. The 3 asteroids in May are not the story on their own. They are the punctuation mark at the end of a sentence that started being written 2 months earlier. Let us start with the objects themselves. On May 7th, 2026, a 6-meter asteroid passed Earth at 0.8 lunar distances. To put that in physical terms, the Moon sits roughly 384,000 kilometers away. This object came within 307,000 kilometers, inside the Moon's orbit, on a rock that nobody detected until it was effectively already passing us. 2 days later, May 9th, a 9-meter object, closer. 0.5 lunar distances, 192,000 kilometers. If you scale that down to the size of a football field, the Earth sits at one end zone, and this asteroid passed the 50-yard line. The Moon was behind it, not in front. Then May 11th, a 12-meter object, the largest of the 3, 0.3 lunar distances from Earth, 115,000 kilometers. For reference, some of our own satellites orbit farther out than that. This asteroid, 12 meters of dense rock traveling at tens of thousands of kilometers per hour, threaded inside our satellite infrastructure. Each object was larger than the previous one. Each one came closer. The sequence is not random variation. It is a gradient. And in geophysics, when you see a gradient, you ask, what is producing the slope? That is the question that Stephen Burns, a geophysicist who has been tracking near-Earth object activity publicly, put on the record. His word was anomalous. Anomalous is a specific scientific term. It does not mean unusual in a casual sense. It means the observation does not fit the expected statistical distribution of the data. One close flyby in this size range happens. It is logged, it is noted, and it is filed. 3 close flybys inside the lunar distance in under 7 days, each one progressively larger and closer, does not fit the model. Now here is the thing that should stop you for a moment. 6 meters, 9 meters, 12 meters. These are not extinction-level objects. A 12-meter rock entering the atmosphere would produce a significant airburst, potentially equivalent to a small nuclear weapon in energy release. It would destroy buildings across a wide radius. It would not end civilization, but the detection problem is not about what these specific rocks would have done if they had hit. The detection problem is about what it tells us regarding the objects we are not seeing. If we cannot detect a 12-meter asteroid until it is already inside the Moon's orbit, we absolutely cannot guarantee early detection of a 50-meter object, a 100-meter object, or larger. The miss is not the emergency, the blind spot is. And that blind spot has a technical explanation that planetary defense scientists have been aware of for years without a fully funded solution. Stay with me, because this is where the story gets structurally important. We are going to come back to the detection architecture problem in the second half of this video, and when we do, the numbers are going to be more uncomfortable than anything I have said so far. To understand why none of these objects were detected in advance, you need to understand how asteroid detection actually works. The global network of telescopes that watches for near-Earth objects is primarily designed to sweep the sky in broad, repeating patterns and flag anything that appears to move against the background of stars. It works well for large objects. The problem is aperture and timing. A 6-meter rock in deep space reflects almost no light. It is essentially invisible against the darkness until it gets close enough to reflect sunlight with enough intensity for a ground-based telescope to register a signal above background noise. For objects in this size range, that detection threshold is typically crossed somewhere between 1 and 3 lunar distances away. By the time you detect it at 1 lunar distance, depending on its velocity and trajectory, you may have hours before closest approach. Not weeks, not months. Hours. That is not enough time to evacuate a city. It is barely enough time to issue a warning. For the 3 objects that passed in May 2026, the detection windows were consistent with this exact problem. This is not a secret. The 2005 Georgie Brown Act directed NASA to detect 90% of near-Earth objects larger than 140 meters by 2020. We did not hit that target. The goal was revised. The revised goal was revised again. The NEO Surveyor Space Telescope, which would dramatically improve detection capability by operating from space rather than through the atmosphere, has been repeatedly delayed due to budget constraints. So you have a surveillance gap that is known, documented, funded inadequately, and still open. And into that gap, in a single week in May 2026, 3 objects passed through our celestial backyard without so much as a preliminary warning to the public. That is the architecture problem. Now let us place it inside the larger pattern, because May did not appear out of nowhere. The week of May 7th through 11th was preceded by a 2-month period of elevated near-Earth activity that most people never heard about, because it happened in a register that sounds innocuous until you look at the numbers. Fireballs, not asteroids in space, rocks entering the atmosphere, burning up overpopulated areas, shaking windows, sonic booms. The American Meteor Society, which tracks fireball reports submitted by public observers across North America, recorded March 2026 as the single highest month for fireball sightings in its entire recorded history. Every month, going back decades. And March 2026 broke the record. That is not a routine data point. That is the chart going vertical. And I promised you something was still coming, that something is next. Let me give you the specific events from that elevated period because the abstract phrase fireball activity does not convey what actually happened on the ground. In March 2026, fragments of a fireball struck houses in Texas. Actual recoverable meteorite material punched through residential roofing in a populated American suburb. Nobody was killed, but the fragments were physical, tangible, sitting on the floors of people's homes. The same month, fragments were recovered in Germany. 2 separate impact events on 2 different continents, both producing recoverable material, both in the same calendar month that broke the all-time fireball record. These are not reports of lights in the sky. These are rocks that physically arrived on Earth's surface inside 30 days. Then a fireball over Ohio produced a sonic boom loud enough that it was widely reported across the state. A sonic boom requires an object to have sufficient mass and velocity to compress the atmosphere ahead of it into a shockwave. The Ohio event was heard, felt, and documented across multiple counties. 3 events, Texas, Germany, Ohio, inside the highest fireball month ever recorded. Then the 3 May asteroid flybys followed immediately after. This is the point where I want you to pause and think about what a pattern like this usually means in science. When you have a baseline, the historic average of fireball and close flyby events, and then you observe a period that exceeds that baseline across multiple independent metrics simultaneously, the standard scientific question is whether the events are correlated or coincidental. Coincidental would mean that March's record fireball month and May's triple close flyby week are statistically independent, that they occurred close together in time by chance, that the underlying rate of near-Earth activity has not actually changed. Correlated would mean that something about Earth's position in the solar system, or the density of material in the region of space we are currently moving through, has produced a temporarily elevated flux of incoming objects. Here is the uncomfortable truth. We do not have enough data to definitively answer that question yet. The scientific community is actively discussing it. What we do know is that the 2 explanations produce very different implications. If it is coincidence, we monitor and move on. If it is a temporary elevated flux, the question becomes, when does it end? And what else is in the pipeline that we have not detected yet? And here's the moment I promised you earlier, the unexpected insight that rewards people who stayed. The detection gap does not apply equally to all sizes of incoming objects. For objects above 140 meters, our survey coverage is reasonably good. For objects between 50 and 140 meters, it is incomplete. For objects below 50 meters, which includes everything in the 6 to 12 meter range that passed us in May, our coverage is essentially statistical. We know the population exists. We cannot see the individual members until they arrive. So let us close the loops. I told you at the start that this story is about more than 3 asteroids. I told you the detection failure was more significant than the flybys themselves. Here is where those threads converge into a single uncomfortable conclusion. The planetary defense community has known for decades that the sub-50 meter size class represents the most likely impact event that could kill large numbers of people without giving any prior warning. Not the extinction-level impactors, those we would likely see coming, the city killers. Objects in the range that could hit with the energy of a nuclear weapon and arrive with hours of notice or none at all. The Chelyabinsk event in 2013 is the reference case. A 20-meter asteroid entered the atmosphere over Russia. Nobody detected it in advance. The shockwave injured over 9,900 to 300 people. Windows shattered across 6 cities. The energy release was 30 times the Hiroshima bomb. If that trajectory had been slightly different, it would have been a direct surface impact over a populated area. Zero warning, zero mitigation. The 3 objects that passed Earth in May 2026 were in the 6 to 12 meter range, smaller than Chelyabinsk. But the detection timeline was identical, essentially 0 advance notice. The difference between a flyby and an impact is trajectory, and trajectory is a function of initial conditions that we cannot measure on objects we cannot see until they are already at the doorstep. Now place the March fireball data back in. The surge in atmospheric entries, the recoverable fragments in Texas and Germany, the sonic boom over Ohio. These are objects that did not miss. They entered the atmosphere. They were in that same sub-50 meter class. And they arrived during the same 2-month window that produced the May flybys. Elevated activity across both metric categories simultaneously. The NEO Surveyor telescope, if funded and launched on its proposed timeline, would expand our detection capability dramatically by operating outside the atmosphere and covering the sunward blind spot that ground-based telescopes cannot observe. Objects approaching from the direction of the sun are essentially undetectable from the ground until they pass closest approach. NEO Surveyor would close that gap. It remains delayed. Stefan Burns was not being alarmist when he used the word anomalous. He was applying the correct scientific language to an observation that does not fit the expected baseline. 3 inside lunar distance flybys in 7 days, in a size class with essentially no advanced detection capability during or immediately after the highest fireball month on record. That is an anomaly in the technical sense. Something is producing a signal in the data. We do not yet know what. Here is where we land. The 3 asteroids that passed Earth in May 2026 were not catastrophic. Nothing hit, nobody was hurt. By the standard most people use to define a crisis, this week did not qualify. But the standard most people use is wrong. The correct standard is not whether impact occurred. It is whether the systems responsible for protecting the planet from impact had any meaningful opportunity to act. And in the case of 6, 9, and 12 meter objects passing inside the moon's orbit in a single week, the answer is no. Not because the people in those systems are incompetent, because the architecture is underfunded, the detection tools are inadequate for this size class, and the political will to fix it has not materialized even after Chelyabinsk. The March fireball surge broke a record that had stood for the entire history of organized fireball tracking. The May triple flyby sits in detection logs that almost nobody has read. These are not isolated data points. They are part of a documented, measurable pattern that arrived in a 2-month window and quietly passed without triggering any public conversation at the institutional level. The Chelyabinsk asteroid was not detected until after it had already exploded in the atmosphere. The 3 May 2026 asteroids were not detected until they were already making their closest approach. The pattern in the detection failure is not a coincidence. It is the same gap, the same size class, the same blind spot, recurring because the infrastructure to close it has been deferred again and again. The math does not forgive deferred maintenance. 3 asteroids, 7 days, 0 warning. That is the record now. That is the baseline we are building the next chapter on. And the next chapter has not been written yet. If this kind of story is what you come here for, the data that does not make the headline assembled in one place, subscribe, because we are going to keep tracking this as it develops. The window is open. The clock is running.